In this video tutorial I will show you how to interface a dot matrix display with 8051 microcontroller, and how to display character on it. Let's start the video. Welcome to Star Technology 5G. A dot matrix is a display device that contains light-emitting diodes aligned in the form of a matrix. This dot matrix display is used in applications where symbols, graphics, characters, alphabets, and numerals are needed to be displayed in static as well as scrolling motion. Construction of dot matrix display. In a dot matrix display, multiple LEDs are wired together in rows and columns. The matrix pattern is made either in a row anode and column cathode or row cathode and column anode pattern. How does a dot matrix display work? For example, if we want to turn on the first LED of the dot matrix display, we will give him a positive supply voltage if the anode is connected to the row, and provide a negative supply voltage to the first pin of the column. The first LED of the dot matrix display will turn on. If we give positive supply to the third row of the dot matrix while negative supply is connected with the first column, then the third LED is also turned on. If we want to display character A on a dot matrix, we have to turn on all rows and columns one by one. First, we have to send the first row data, and then send first column data. After that, send second row data and send second column data, and send all rows and column data one by one. When we repeat this process again and again, the dot matrix displays the A character on it. We will use these binary codes in our program. First, we will draw its circuit in Proteus. The circuit is ready. Now we will write its codes in Keel Microvision. I already wrote the codes. I will paste this code here. Now I will explain these codes. Row equal P2. Define port 2 as row. Rows are connected with port 2. COL equal P0. Define port 0 as column. Columns are connected with port 0. Main program. Again, that is a label. Move row #ADH. Copy ADH to row. ADH is the hex value of 10000000. Rows are connected with port 2. Move COL #00H. Copy 00H to column. Columns are connected with port 0. A call delay. Call time delay. Here is the time delay function we are using in this program. Move row #40H. Copy 40H to row. Its binary code is 01000000. Move COL #3FH. Copy 3FH to column. Its binary value is 00111111. A call delay, call time delay. Move row #20H, copy 20H to row. Move COL 44H, copy 44H to column. A call delay, call time delay. Move row #10H, copy 10H to row. Move COL 84H, copy 84H to column. A call delay, call time delay. Move row #08H, copy 08H to row. Move COL 44H, copy 44H to column. A call delay, call time delay. Move row #04H, copy 04H to row. Move COL #3FH, copy 3FH to column. A call delay, call time delay. Move row #02H, copy 02H to row. Move COL #00H, copy 00H to column. A call delay, call time delay. Move row #01H, copy 01H to row. Move COL #00H, copy 00H to column. A call delay, call time delay. SJMP again, small jump to again. Here is again label. And it will repeat this loop again and again. Now click on the build target. Hex file created. No error, one warning. Now I will download this hex file into the microcontroller. Click on microcontroller. Select file. Click on start. Now you can see the dot matrix display showing character A. Thank you for watching. Please subscribe to Star Technology. Please like and share the video.